Hey everybody, it's Miss Williams, and this is Chapter 1, Section 3 of Statistics, describing quantitative data with numbers. So, the first thing we're going to do is talk about the mean. I know you've done mean before. The mean is denoted by X bar, and to find the mean, you add up all the observations and then divide by the number of observations you had. Now, here's where we have to be careful. You use X bar when you refer to the mean of a sample, and you would use the symbol mu, that's that symbol at the bottom down there. Use mu when you calculate the population mean. So if I just took the average age of, if I want to find the average age of all the seniors at McGavock High School, if I found out every single person's age and then took the average of that, that would be a mu. But if I just took the kids that were in one of my statistics class, because you are all seniors, and just did the average of you, you would be a sampling that I would relate back to the entire population. Another way to measure center is the median. Remember, median is the middle number when the observations are in order from smallest to greatest. Okay? If there are two numbers in the middle, add them together and divide by 2. So, comparing mean and median. When a distribution of data is roughly symmetrical, the mean and median will be very close together. If the distribution is exactly symmetrical, then the mean and median are the same number. If the distribution is skewed, now this is important, if the distribution is skewed, the mean is usually further out on the long tail than the median. Alright? So, make sure you know that if I gave you a skewed graph, you would be able, and drew 2 lines on there, you'd be able to tell me which one's the mean and which one's the median. Okay? The mean is further down the skewed part. Calculating spread. So remember SOX, shape, center, spread, and outliers. Alright, so when they ask you to talk about the spread of the data, spread can be used with interquartile range, IQR. So how do you find the interquartile range? Well, first you have to put the observations in order, find the median, then you find the first quartile, which means you cover up the top half of your data and you just look at the bottom half and treat it as its own set, and you find the median again. Then for the third quartile, you do the same thing, cover up the bottom half of your data and find the median of the upper half. Okay? To find the interquartile range, it's just a number, not a range actually. It's how big it is. So you would take Q3 and subtract Q1. Whoops, sorry. So interquartile range are how you found outliers. The formula to identify a lower outlier is you take the Q1 and then you subtract 1.5 times the interquartile range. To find an upper outlier, you take Q3 and add 1.5 times the interquartile range. If there's a number that lies outside those numbers, lower than the first formula or higher than the second formula, then it is an outlier. The 5-number summary. This is what you need to make a box plot or a box and whisker plot. Okay, they usually don't call it box and whisker plot anymore. They just call it a box plot. So you're going to need the minimum. Your 5-number summary is the minimum, Q1, median, Q3, and the maximum. Put the numbers in order. Find the median, find Q1, find Q3, and then identify your max and min. The box is made up of actually Q1 and Q3, and there's a line somewhere in the middle of the box, not necessarily the center, but the middle of the box that represents the median, and then you extend your whiskers out to the maximum and minimum. Another way you can identify, compare spread is with standard deviation. Standard deviation is associated with mean, and it measures the typical distance of the values of the distribution from the mean. So this is a big, complicated equation, but I'll show you how. You need to know how to use it, and I will also show you how to do it in the calculator when we get to class. Okay. So all this says is you take every data point, you subtract the mean from it, square it, add all those up, and then divide it by n minus 1. And finally, we are being introduced to how you solve statistical problems, and this is how we'll do a lot of the stuff this year. When we talk about long problems, that would be examples of things that would be on the written portion of the AP exam. So if you have a statistical problem, you need to state, plan, do, conclude, which means you state what you're trying to answer, you plan out and tell someone how you're going to do it, then you actually perform the operations or the computations, and finally you give your conclusion in the real world setting. Okay, look through Chapter 1, Section 3, in your book if you have any questions, and we'll work some problems when we get back to class.